Hey, how are you guys? So, I came across this little heating device on AliExpress. It says 400 watt professional PTC heating plate chip VGA soldering ball split aluminium lead remover welding station with demolition board tool. I think they're trying to get as many words in as possible for searching or something like that. But in any case, I bought one of those things in the past, for $12 or $13. I think it was cheaper when I bought it. But it lasted about uh, not very long at all, and I've actually converted that. I used the heating element in it and made a tea or coffee mug heater out of it. I've got a video on that in actual fact, and you find that you have more professional devices here, like $56 for one with a temperature gauge on it and so on. Um, I was wondering if you could use one of these guys here for doing that sort of job. Now, it's kind of odd. In the one of the picture here says it's 300 watts and they claim to be 400 watts there. I have seen a draw when you first turn it on up to 4 amps, so I guess the 400 watt must be accurate, but only for a short time. When it reaches temperature, it actually goes right down to less than an amp of runs on 110 volt AC. So therefore you can see that if it was drawing nearly 4 amps, it would be, at least 400 watts. In any case, I bought one of those things, and I also ordered, I haven't received it yet, a little metal box there that I'm planning to mount it on. Okay, so what I have done so far is I have hooked this thing up, and I have got a variac going over here, which is currently set at 10 volts. I decided I'm going to mount this in that metal box, so I've got a fuse holder here, and I put a switch on there, and this thing wasn't grounded, so I put some ground lead over there, which you can see connected to its little leg right now, but it will be connected to the metal box. Inside the metal box, I'll be putting some circuitry eventually for experimentation. But right now we have this thing over here, and I have a thermal camera here, which I've checked and it's fairly accurate. But right now I am curious to see what temperatures I can set this to. I do not know what's inside of this thing. It just there's like a slot in here, as you can see, and I cannot really see what's in there. It seems that it must have some kind of mechanism there to limit its heat, because as I said, when you first turn it on, and we'll be looking at that, it can draw up to 4 amps close to it, and then once it gets to the temperature that it is the maximum temperature that it can handle, it will actually go to it reduces its current, and it doesn't get any hotter. So let's have a look. If we at 10 volts, I can't really tell if it is. We'll have a look at that in a minute with the camera there. So if I let me see now, this is the line, set it to 20 amp mode. I think there's some. I've got it connected also to the multimeter. You can see the voltage AC at the top there. I've got it set to 10 volts right now. I'm curious what temperatures it might produce at different voltages. So let's turn on this device here. I will bring in the other camera so that we can see it from the top. It's enough to 25 volts. Now it says it's drawing 0.3 amps. Is that doing anything? 29.2, 0.3, I guess. This is kind of an experiment to see what voltages I can apply it to get different temperatures. (31 degrees), 80 milliamps. It's obviously needs. I have no idea what kind of circuitry is in there, if there's any controller in there or not, or if it's just a bare heating element with some kind of cutout if it hits a high voltage. Now I'm starting to feel a little bit of warmth there. Not much though. 32. Let's give it 50 volts. That's like half. (180 milliamps), I guess. Let's set it to 2 amps scale. Yeah, 199, 200, 36. Interesting. I can feel it. It's warm to the touch now. 58. So at 50 volts, it'll eventually probably warm up a bit more. 39, 39.5. I guess it's going to be like around 40-ish degrees. It's approaching, not quite half an amp, but getting closer. 48, 49, 50 degrees, 51, 52. It's counting up. That's getting too hot. Not comfortable to touch anymore now. 57. Still counting up. 58, 59. 61, 62, 67, 68, and as it gets hotter, the current seems to go up. I've also tried this thing with a, this is like a triac type controller here, which is normally used for, you know, routers and motors, and it kind of works with that as well, but it's not. If you set it to one particular setting, it'll settle at that, but then if you turn it right on and then turn it to the same setting, then suddenly it'll draw a lot more current. So it's kind of interesting. Okay, it's approaching 1 amp now, and it's getting to 95, 96. It's going to be 100 degrees C, 120 volts. Now the current's going down again, so it might be getting close to its maximum temperature. which previously I saw it going right up to 200, close to 240 degrees Celsius. I can feel the heat radiating from it. 239, 240, actually goes a bit over 240. 241, 242, but as you can see the current is starting to count to go back now. It's reducing. I think it settles on like 600 odd milliamps or something, 0.6 amps. Yeah. And okay, 243 degrees Celsius at the hottest place, and 237 closer to the edges or something. Yeah, just over, 242, 243, and it seems to settle on about 600 or 700 milliamps, less than an amp. It maintains the heat. At that temperature, you can put a PCB on there. Let's put one on there. Let me have a look. I have an old little PCB here. Okay, I just removed the little multimeter current meter there. Now I'm just curious, I've got this little PCB here. What happens if I put it on top of it? Get some, hold it down here. Now underneath there are some pins on some of these components, through-hole components, so it's not actually touching other than the pins. The question is it hot enough to melt the unleaded solder that's on there? I guess. What's the temperature of the PCB, I wonder? Alright. Well, without touching the thing directly, it's just because as I said, there is pins sticking out past the it looks like it's 100 counting up 160. Could use it as a preheater, of course. Use a little bit of hot air. And it should be very easy to remove some of these components since it's already preheated. Like that. Yeah. Takes a lot less effort than it does when you've got these little components here. Yeah, no problems. But that it's still counting up. Yeah, it is 181, 182. perhaps eventually it might get hot enough for these components to come off. Put some gloves on so I don't burn my fingers. It does work as a preheater, and it does work, and we'll try that out in a minute. Putting new components on the PCB, because the PCB will be touching the surface, but with these guys here, oops, they have all these pins sticking proud of the PCB, so PCB cannot make a contact. Okay, so we didn't do too great on this little board here with the pins sticking out because it wouldn't make a contact. Here I have a little board that has no components at all on the other side, so let's drop that on there and have a look if we can desolder that kind of little board here. And we'll hold it down and let it warm up and see what happens. We've already determined that, I see some smoke coming off, so that's a good sign that something is melting. Yeah. There you go. Yep. We'll be able to desolder and solder the components on this, and I'm telling you, this is a easier way to remove these components. Oh, little track came off. Then it is using hot air sometimes, because some of these things are plastic and they may in fact melt if you use hot air. Yeah, you can just pick them off. So that's working. So yeah, I think this is a useful piece of equipment for certain things, and we'll leave it at that. Okay, so I put some solder paste on this little PCB and put a few little components on there. A little resistor and this opto isolator over here. This solder paste has got flux built in, and if we turn the heat up, it should solder them on. So I'll just turn it on and we'll see what happens. I had to turn it off while I was putting the paste on, so it's cooled way down again. Take a few minutes to get to heat, I guess. All things being equal, once the solder starts to melt, it should have some surface tension and pull the little legs onto the pads, hopefully. We'll see what happens. Okay, I think it's starting to happen. Yeah, there it goes. This little guy needed a nudge. Yep. So there we go. It has actually soldered them on, I believe. Let me remove the PCB here. Yeah, it actually did a pretty good job soldering those on. I'm also wondering if it gets, you remember in the last soldering test I put this coin, soldered that coin on here with a soldering iron. See if it is, if it can get hot enough to remove that coin from there. Yeah, I'm looking at the little PCB. I guess it may be a little bit hard to see unless I put it on the microscope, but it did actually a good job soldering that on. Yeah, I think it's warming up. Yeah, it does get hot enough. Move this coin from there. This is normal leaded solder, but this little PCB here, because it has, as you can see, it has lots of little legs sticking out over here. It just wasn't making a contact with the heating plate, and it was not hot enough to get the components. Although it did a good job at preheating it. It made it a lot easier to use a bit of hot air. But if I was to remove all the true hole components on there, I suppose that it would have been hot enough to remove the other components. But it doesn't matter. It was good for preheating, and then use a bit of hot air with it, and all these little components came off. Okay, so now we're going to be waiting for the little case, and then I'll mount it on there, and we'll see what we have and finish the video on that. Okay, well, the little box came in the mail, and I have mounted the heating device on there, and I put a switch on there so you can switch it on. The fuse was there before, and I added a little neon light to it over there so I can see when it is switched on. Let me turn on the power. When I switch it on, a little light comes on, so I know it's on. I've already tested it, it's working, so all I need to do now is to screw the little screws in there on the top cover, like that. Okay, so this is going to be useful for soldering my little PCBs using solder paste and surface mount components. And I think that I have other devices that I can use for lower temperatures that are, that have controls on them that I can set the actual temperatures on. I have several, so this will be useful for just for soldering and desoldering. So that's it, and don't forget to like and subscribe and so on, and I will see you guys later. Bye bye.